Right. Typically, the most common graphic organizers we use with statistics, there are three types. Those are the histogram, the frequency polygon, and the ogive. Now, you've probably heard of the first two, the histogram for sure. What is a histogram? It's a frequency chart based, and how is it set up? Two intervals, right? Where each interval touches the previous interval it touches. So it looks like this. One, two, three, four, five, six. So what do you think a frequency polygon is? What's a polygon to begin with? Yes, what kind of shape? What does poly mean? Poly means many. Polytheistic means many religions. Polymorphic means many changes. Polygon means you have many images, many shapes. The way these look, or start from zero. Where at each data point, it corresponds to a point on the graph. That's a frequency polygon. Where this is the frequency, this is also the frequency. Now what's an ogive? What does an ogive look like? Okay, let's think about what did you remember from high school? Yes, even though we don't use mostly we use it in statistics. We don't use it in algebra too much. The ogive is a specific graph where you see how the histogram is just as each interval goes. You have to look what it says. The ogive starts with the most frequent and it goes down from there. So it goes from the highest frequency to the lowest frequency. And that way, you look at yours, the first one's going to give you what answer is that going to give you. It's just not an interval, it's just that one frequency. So that's it. So that's how it's set up. So let's look at this data set. All right, so we have the class, each class right here. I want you to create the histogram and the frequency polygon from this data. So how do we do that? What's the first thing we have to do? We have to do something else before that. Right. We have to make sure every possible data is allocated for. So this is when you subtract 0.5 and add 0.5. So it's 99.5 to 104.5. 104.5 to 109.5. 109.5 to 114.5. Okay. Because we have to make sure everything's set up. And then what we would do next, we would look at our data set. And then if we look at the data set, what we would do with that? What do you graph? When you graph these things, what are you actually graphing to? What are you comparing? What are you looking at? Okay. But what do you have to know about the data? Well, our next step would be very small, would be the tally. You have to know where they belong. Where's the data? Which class does the data belong to? So after we do the data, we have to know the frequency. So the tally marks would be the intermediary step. Here's a back step. How do we create the class list? How do we make these bounds? How do you make this first column? Before that, what do you gotta do? To create this column, what do you have to do? You find the range. Yes, you have to find the range and then do what with the range? Oh, you get the maximum. I didn't know. The range itself is the highest and the lowest, see how far they are apart. Then you divide by n. What does n represent? What about the classes? The number of classes you want. Because that's going to be important. So in this case, what is our n? No. 7. Because we have 1, 2, 3, 4, 5, 6. We have 7 classes. So our n is 7. And then from there, what do you do? Well, yeah, we start with the lowest. Right, and we do that. We start with the lowest, and we have the range, the class range. This is, of course, modified a little bit but typically you'd go from the class size, you go from the smallest, add that number, go to there. So here we're adding 4. But what is the actual class width? 100 plus 4 is 104. How many numbers are there in there? 5. Why is it 5? It's 100, 101, 102, 103, 104. So from there, we know that both of these numbers, the upper bound and lower bound, if we add 5 to those, we get to the next one. So that's how we create our sets. All right, now what do we do? This is a first important step. What do we do next?
So you find the end of the frequency.
How?
You add all of them.
So you add up all your frequencies and it equals n. Why is that important? Nope. To see if you did it correctly. Because you know how many data sets you collected. Let's say it's 100. If you do this and it doesn't equal 100, row, you have to go back and redo it. Something went wrong. You misput a number. So that's the first check here to make sure you have the actual numbers of data sets you're supposed to have. Okay, so with this, what can we create with this bit of information here? Yeah, with what we have here, what can we do with it? Yes, you do. You have to put it all together now. What graph can we create with this information? Histogram. Because we have the intervals, we have the frequency. That's exactly what the histogram is. So our first thing is create a histogram. Your x-axis are the intervals, and the y-axis is the what? Frequency. So our data goes from 99.5 to 104.5 to 109.5 to 114.5 to 119.5, 124.5, and 129.5. And it stops at 134.5. Two, 4, 6, 8, 10, 12, 14, 16, 18, 20. Why did I count by twos? Well, because what's my highest frequency? Is 18. I have to make sure I have all those in there. Because if I just did it by ones, how tall it'd go pretty tall. So I condensed it by using twos. You can, if you need to, if you wanted to, you can use threes. From 0 to 3 to 6 to 9 to 12 to 15 to 18. So let's look at our frequency. Our first one, between 99.5 and 105, is 2. Let me make this line look better. So 2. And it's always safe to put the number on top of it. The next one is at 8. And keep on going. So the next one was 18. And the important thing about the histogram is the bounds, the sides of the walls touch. Or they're supposed to touch. And then the next one between 114 and 119.5 is 13. Then 7. Then 1 and 1. So that's a histogram. Pretty straightforward, pretty easy. So the next one, how do we do a frequency polygon? Ooh, good question. Or option 3, neither. Frequency polygon. The frequency polygon, because we have the frequencies from this, right? So it's the frequency polygon, it takes this interval and finds one point that represents that whole interval. How do we do that? What number would represent this first interval? Think of it, how would we find the mean? Remember we talked about the mean, median, mode last time? If we had intervals, what do we use to calculate the mean? We can't use the whole thing because we have to have one number that represents this list. What number do we? Now we need to have the midpoint of each class, because we're going to use that midpoint is going to represent that class for us. How do we find midpoints? Right. It's the average. Add the two numbers and divide by 2. And these guys. So what's the first one going to be? So we do 104.5 plus 99.5 divided by 2. It's what? Right. Because 104.5 minus 99.5 is 6. 6 divided by 2 is 3. So what this means is it's going to be 3 from the lowest, 99.5, add 3 to it. 102. Done. So what's our next number? If this one's 102, what's the next one? What's that? 110? How'd you get that? Because remember, this one starts off, the second list ends at 109, can't be 110. What do we notice? Remember, from the lower bound to the lower bound of one set to the lower bound in the other is how far away? How do we go from 100 to 105? Add 5. Same thing with the other bound. So we do the same thing here. So 102 plus 5 equals 107. 107 plus 5 is 112. Plus 5 again is 117. Plus 5 again, and so on and so forth. So now we use these points. These are our x-axis points. And we use the same frequencies. So create your graph using those. Frequency polygon. So the first one we had, I can get my data here. The first one we had was at 102. Then it was 107, 112, 117, 122, 127, 132, now, and our frequency is the same thing. We're going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So at 102, we had how many? We had 2. So put a dot there. At 107, we had 8. Put a dot there. Then we had 18 at 112. And then we had, where's the next one? 13. Then 7. Then 1 and 1. Now, these numbers here represent the midpoints of each class. So how do we draw the graph? Just connect the dots, pretty much. But there's one thing you have to do, make sure at the very end, after we connect all the dots. So for the frequency polygon, you first have to find the midpoints of each class. And then those are the points that you're going to use to represent that interval. But with frequency polygons, you always start and stop on the x-axis. Because that's where the data starts and stops. It starts and starts on the x-axis itself. So far, so good. Now, what do we notice about both of these graphs? Let's say basic shape, yes. Basically, if you think about it, the only real difference about these is the width of the graphs. These intervals are the midpoints of the intervals. So all we're doing here is connecting these midpoints. That's all there's difference. So if you have the histogram, just find the midpoints and connect the dots, you're done. Get rid of those fat intervals. Pretty easy. These are the most common used graphs. Let's look at an ogive now. Same data, let's use the ogive. We have to first calculate the cumulative frequency of each class. What does that mean? Yes. Now I'll put it over here. Yeah, cracky. What this means remember, the cumulative frequency is simply a running total. So what's the first number in my running total? Yeah, it's this one, 2. We're only looking at the frequency column. So this one's 2. What's the next one? It's a running total. So we add 8. Because we start with the first frequency, then we add the next frequency, then we add the next frequency. 10 plus 18 is 28 plus 13, 41 plus 7, 48 plus 1, and then one more. These two numbers should equal. If they don't, then we can't do anything with it. Now, Remember I told you in the last graph we just drew, where's that? The last graph we just drew, remember the frequency polygon? Remember I told you it starts and stops at the x-axis. Why? Here's the reason why. Because if we would had the class bounds, the frequency, the cumulative frequency, let's do the first couple of them. What we're looking at here, when we're doing these calculations, remember our bounds were from 99.5 to 104.5. The next one was 104.5 to 109.5, and then 109.5 to 114.5. All the way down, we keep on going. Man, I might as well do it all. 114.5 to 119.5, 119.5 to 124.5, 124.5 to 129.5, 129.5 to 134.5. These are the bounds. I put in the wrong place. And we had the frequencies of 2, 10, 18. No, it was 2, 8. 2, 8, 18, 13, 7, 1, 1. So the cumulative frequency was 2, 10, 18, 41, 48, 49, 50. So what goes on between here? These are between these. Before this is what's below 99.5. What's above 103, 134.5. The reason we have to ask those two questions is what if we have or something called outlier? What's an outlier? Yeah, it's something that's very far outside. Whereas if everybody made scores between 99 and 134 and somebody made a 300, their score's all the way out here. That's an outlier. Or if they made a 0, they're an outlier. So that's what we have to have those contingencies just in case. So how many numbers are below 99.5? 0. How many are above 134? 0. So that's why we have to keep those. Other frequencies are safe. So as that's to come at the very end, they go back down to zeros, the beginning and the end. So let's look at the Ogive. Let's do the graph. So how will we do the graph of this? What's on the x-axis? Yeah, but it's not really the intervals. Now it's just now they're no longer intervals. They are simply the bound points. So we have the reason being because we're no longer in that same order. We have 99.5. We have what's the next one? 104.5, 109.5, 114.5, 119.5, 124.5, 129.5, and 134.5. Two, This is the, okay, which are the class intervals. We're looking at the beginning points. What's in the vertical axis? The cumulative frequency, because this is an Ogive graph. Why is that important? Because what's the highest frequency you can go to? Yeah, so we have to go from 0 to 50. And how we're going to do that? That'd be 5, 10, maybe 10, 20, 30. How about fives? If we did fives, we can have a lot more of those, make it easier to graph. Because if you do the spread too far, then it's going to be hard to put things in the middle. So the first one, 99.5, that's 2. That's all the way down here. 104.5, what's that one? That one goes to 10. One 109.5. That one goes all the way up to 18. There's 20. So just short of that. Then 114 goes all the way to 41. Then 119 goes to 48. Then 49. Then 50. Because you're putting these numbers in reference to the beginning points. Because remember, we're looking at what numbers, this is a cumulative frequency. How many numbers are below 99.5? 0. How about less than 104, for less than 99.5 is 2, less than 104 is now 10, that's that, and so on and so forth. It's a running total. Now we connect the dots. And that's your Ogive graph. What would you use that for? What would you use an Ogive graph for? What's that? How do you mean? You're right, but how would you mean? Then we use a histogram. That's how many is a question of frequency. What is this graph really showing us? Yes. So how would you not put that in math terms? No. What we're looking at here is the rate of change. Because each of these intervals are the same. So between the first interval, it has this increase, then this increase, and all of a sudden it jumps up. So the more steep the line, the more it increases. And then the more shallow the slope, the less active it became. So yes, it's a rate of change that you're looking at. So the ogive is you have to get a cumulative frequency and then plot those at the beginning points. How do we find the relative frequency? And what does it mean? The answer is in the name. Relative frequency. What does it find? Yeah, it tells me the frequency of that interval relative to everything else. That's why it's called relative frequency. It's in relative comparison to everything else. What's the formula for relative frequency? Because each individual set divided by n. So here's, we're gonna have the classes here, the frequency. I'll even look at the cumulative frequency. Now look at the relative frequency. This is below 99.5. This is 99.5 to 104.5. 104.5 to 109.5. 110.5 or 110.5. 9.5 to 114.5. 114.5 to 119.5. 119.5 to 124.5. 124.5 to 129.5. 129.5 to 134.5. Okay, so what were the frequencies again? We had, there was 0 there, there was 2 there, 8, 18, 13, 7, 1, 1. And then below 134.5. Look at the beginning and the end rows. We're only looking, when we do these comparisons for the cumulative frequency, we look at the upper bounds. Why? Because how many numbers are there below 99.5? There's 0. How many numbers are there below 104.5? There's only 2. So there's 0. How many numbers are there below 109.5? Those are those 8 and those 2. There's just 10 total. So this is how we would create our cumulative frequency. So we always compare it to the upper bounds. So the relative frequency, we'll have 2 of these actually. The relative frequency is frequency over n. So what is 2 over 50? This is a math problem. You don't find it in your notes. Calculator. What is 2 over 50? I'm sorry about the chairs all being all crunched up like this. So what is 2 divided by 50? Yes, because if we double it, we get 4 over 100. So what's 4 divided by 100? Move it 2 this way, so that's 0.04. How about the next one? We have 10 divided by 50. That's 1/5, which is 0.20. Or you can use a calculator. It's perfectly legit here. I'd rather have right answers than wrong answers. So use a calculator. Use a calculator to check your answers, though. Don't try to just do it yourself. Like we were talking about AI earlier. Don't use the machine to do the work for you. The only thing you do there is the knowledge level will go down, the computer usage will go up. So how about next one? 28 divided by 50. .56. How do we get that? Or if we double it, what's 2 times 28? 56. 56 over 100 is 0.56. Then we do 41 over 50 is very good. 48 over, you guys are making me do the wrong numbers. These are the cumulative frequencies. This is called the cumulative relative frequency. That was going to be the surprise column we're going to do later on. But we'll jump to it now. We can also do cumulative frequencies of, the relative frequencies of the cumulative frequencies. So this is 0.48, 49 over 50, 98.98. What do you notice about these numbers here? Not add up. They eventually all go to 1, which is they're going to the highest level it can go. And that's how that one goes. So what would the relative frequency be? We have to use this column. 0 over 50 is 0. 2 over 50 is still 0.4. 8 over 50 is 0.16. 18 over 50 is 0.36. 13 over 50 is 0.26. 7 divided by 50 is 0.14. 1 divided by 50 is 0.01. No, 2. 1 divided by 50 is 0.02. So do we need to, if we add up all the cumulative relative frequencies, or the relative, if we add this one up, what would that one equal? It wouldn't be 1, so we don't do that. As long as this ends in 1, we're fat, dumb, and happy. The relative frequency, if we add up all those, What should that equal? This one should equal 1.00. So you see all these checks and balances that we have here. So which one do we need a midpoint for? Which one? Not cumulative. Why do we need a midpoint? Look at your notes. Well, in our notes, where do we use a midpoint for? Which graph? Nope. Histogram is a bar chart. Which polygon? The frequency polygon. Needs a midpoint. And don't think that that's the only place we use it, because when we start doing the mean, median, mode, variance, deviations of these are called grouped data, then that's the only way we can do it. We have to find the midpoint as our X value to do the calculations. You know, for example, to find the mean, remember, originally it was add up all your X's, divide by N. But once we have larger groups, then we have the frequency of those. Now, once we have intervals, take the midpoint times the frequency over N. So this is with grouped data. This is ungrouped. And this is just, so these are happening when you have large groups of data widespread. These if you have a small amount of data. You see how the formulas are building up? And this is only talking about the mean, median, mode. We haven't done really talked about variance deviation that much. And that's gonna come next week. But we're gonna do graphing today. Let's see what's more graphs. We talked about that. Okay. Somebody said earlier, when our first graph, when we did the histogram, if it looked like something similar to this, what did we call it? What's that called? Right. We're gonna do a bunch of bell curve calculations later on in this course when we deal with proofs of hypotheses. Right now, the basic bell curve, what we call it is a normal curve. That means the data pretty much has a symmetric shape. Yeah, if all of our data, after we finish graphing it and everything, if it comes out to be a shape, we're lucky, because then our calculations are much easier, and we could find certain intervals on where the data sits. What if your data looked like this? You could call it a plateau. It looks like a table. Very good. We call this a normal distribution. When we say distribution, we mean how the data is spread out. So the normal distribution here, this is uniform because it follows a set pattern. The next two. What does skew mean to begin with? No, what does the word skew mean? Once you use a word, you have to be able to define it. Nope. So in law school, no. We had to carry in law school, we always had to carry a dictionary with us. Anytime we made a statement, we had to have proof of the words we were using. The instructors would say, what does that word mean? What does that word mean? We'd look it up. So when you use a word, don't just say it because you read it somewhere before. You have to understand, what does those skew mean? Well, no, then look it up. That's what we have to do. I would strongly suggest it. If you're going to do any type of communication anywhere, and that's also how people know that you're using AI to do papers for you. You use words like conflagration instead of fire. You use words that we know that your generation has never heard of, that's never even been in your lexicon, but you use it in a paper. Where did that come from? Automatically zero. Prove me that you know what that word means. So if you build your vocabulary, this is in all your classes. Always have access to your dictionary. You have your cell phones out, have access to your dictionary that way. Come on, you can join us in closer. No. There's a difference. I don't want you guys to surf and text and that kind of crap. There's a difference between using something as a tool and wasting time with it. When I see people scrolling, that's not using it as a tool. That's becoming a tool because you're using it as a waste of time. No, I would love for you guys to have your cell phones out. If I could trust you to be mature enough to say, okay, I'm gonna use this, I'm gonna do my calculations with this, I'm gonna do this. Not, oh, I got a text message. This friend's asking me what I'm doing today. Because they're bored out of their mind. There's a difference between what using it and having it out. Go use your, yes, look it up. Welcome back. Oh, no. As long as you're here. Hope you didn't drive here just for this class. No, I'm gonna send them all to you. Now, from now, if anything that happens, I don't want you to get in a traffic jam or accident or a ticket or anything. No, if you're gonna be late, then I might as well stay where you are. And you can log online and watch it online. I know. Yeah, thank you for coming here, but I don't want you guys to ever get any accidents or trouble or anything because if you get here late, you have to park way down there and wait for like 5 buses to get here. So no, but thank you for coming here. But if in the future, if you're running behind schedule, don't stay home and just watch it online. What you get to twist or distort something is distorted. Why is it distorted? Because this is normal. Anything that's not this is now skewed. It's now shaped. It's been forced to another shape. It's been skewed. So you're right. Look at these two. I put them this way specifically for a reason. What's that? Well, you can't tell the difference. You see that this one here starts off small and goes up high. What's that? On what? Well, these are both skewed.
Yeah, they're just different.
And I'm glad you said that because that would lead me into the next discussion. Or we say if it's left skewed, we say it's negatively skewed. If it's right skewed, we say it's positively skewed. Now, the difference between the two, how can you I'm glad you said that. That's very true because it's opposite of what you'd think. The reason I put it this way is think of your feet. What foot looks like this? Your left or your right foot? It's right skewed. Your left foot is it, so it's left skewed. Just think of that way. Just think if you put your feet over it, what side is it skewed on? If it's then it's uniform. I see what you're saying. Some people do have toes that are all straight line pretty much. But then they don't have right foot. They're gonna have a hard time doing the left. But think about it. Your foot, if you look at your shoe, if you look at your shoe, it's built automatically for big toes to be on the left and right side. So that's one way we could do it. I'm glad you asked that question because that is the most difficult problem students have with descriptions of graphs. How about if a graph looks like this? You can say U-shape, but it's more. What is the highest frequency is called a what? Mode. Here we have two of them. So this would be if it's bimodal, that means we have to have something in the we'll have a valley, a a ditch in the middle. Because if they were both in the middle, then there's gonna be one bigger than the other. But since these are separated, that's why it's called bimodal. Bi means two. Yeah, right. If you have enough data sets, you can have trimodal. But there comes to a point where you have so many modals that there's no mode, no predominant mode. So then you say it's a non-modal distribution. But typically we say either it's a mode or bimodal distribution. What else? Well, I guess you could also say this is because you have two sets of data that are it looks like it's two separate sets of data, but you can use either one if you want to as a bimodal or U-shaped. That's the end of that section. Any questions?